Hello viewers, in this video we'll solve this problem, rate of change. Now this is a calculus problem as well. You have a 16-foot ladder, resting against a wall. So let's say this is the wall. And you have a 16-foot ladder, let's say something like this. So this is 16. Now, okay, so let's just say the distance from the wall to here, we call it x, and this distance we call it what? Let's call it y. All right, so what happened? It says the bottom is initially 10 feet away from the wall. That is the initial, and is being pushed towards the wall at a rate of what? 1/4 feet per second. So from here, what do we know? We know that at any point, this is always true. By Pythagoras theorem, we know we always have 16 square to be what? Y square plus what? Plus x square. This is always true. Now, what are we actually looking for? We're looking for how fast is the top of the ladder moving up the walls 12 seconds after the start of pushing. So if initially, let's say the distance from here to here is 10, now you push this ladder here. So let's say you push this ladder okay, let's say you push this ladder here. If you push this ladder a little bit, you push it here, it means this ladder will move here. What will happen? You see that the height will change. So because you are pushing this ladder here, if you push it here towards the wall, because it's pushed towards the wall, at which rate? At the rate of 1/4. So what we want to find is actually want to see what will be the change in this height. What will be the change of y? Because y is going to what? Increase, right? Okay, so here what we can do is, let's start with this one. If you differentiate this, you see both y and x will change, because by the time you push this, x will change, y also will change. So both of them are changing with respect to time. So if you differentiate this equation with respect to time, this is 0, and this is going to be what? 2y. You have 2y. So we'll have 2y dy dt plus what? This is 2x dx dt. Okay. Now we need to know so many things. This is actually what we are looking for. We are looking for this one. But let's put the one that we know first. This is 2y dy dt plus 2x. What is the x dt? The x dt is given. The x dt is the horizontal distance. It's changing at where? It's going to be minus 1/4 feet per second, because you are pushing it. So it's decreasing. You are reducing the what? The original length of the side. So you are pushing towards the wall. So it's going to be minus 1/4. Okay. Now what we don't know is, we don't know what is y, and we don't know what is x. So now we can see that afterwards 12 seconds, because we're interested in after 12 seconds, if you keep pushing this one, if you keep pushing this forward for 12 seconds, at which rate? At this rate, it means it's going to cover a distance here. So we want to know what will be the distance, what will be the horizontal distance left. So after 12 seconds, you will see that what? How do you find distance? Distance is going to be what? Just 1 over what? You are pushing at 1 over 4 at what rate? Remember, it's going to be the original distance is 10. So you have 10. You have to subtract 1 over 4, which is the rate, times what? You are pushing for how many seconds? For 12 seconds times 12. So try to understand this. Remember, 1 over 4, what is 1 over 4? Even from the units, you see, 1 over 4 is what? Is 1 feet over what? Over 4 seconds, right? If you multiply this by what? 12 second, 12 second. So look at what happened. Second will cancel second. So what is the unit here? It's just 12 times 1. 12 times 1, which is 12, divided by 4. So this is going to be 3 feet. But here we have 10 feet, which is the original what? The original distance before you start pushing. So it means that after 12 seconds, the value of x, which is this horizontal distance, will become just 10 minus 3, which is going to be 7 feet. Okay, so now let's continue. If you look at this now, you have your x. If you come here, remember I did something here just by differentiating. So what do we know? We know x now. So it means after 12 seconds, our x, this value of x will be what? Will be 7 feet. And if we know the value of x, we can definitely know the value of y, right? Because here we already have an equation. This, let's call it equation 1. And this equation relates both x and y. So let's go back here, and using this equation, we can see that what? Y square is going to be 16 square minus what? Minus x square. So this is y, it means is going to be the root of what? 16 square minus, but which x are we going to use now? We're going to use 7 square. Okay, now this is going to be, so our y is going to be 16 square, which is 256, right? I think minus 49. So our y, it's around, I think, root of 207, right? Okay, now we are almost done. So let me change to the red pen. Okay, now I will come back to this equation here and start plugging things there. So this is 0, the left hand side is 0, is equals to 2 times y. What is y? Remember, we have y now to be this one, which is the root of 207. Then multiply by dy dt. This is actually what we are looking for. Then plus 2x. What is 2x? Is going to be 2 times, what is our x? Our x is going to be 7. Then times minus 1 over what? 1 over 4. Remember, this minus 1 over 4 is from where? The x dt, which is the rate at which you are pushing. So it's minus. Now from here, I think we can get everything. We can have 0 is equals to root 2 times root of 207 dy dt. This is going to be a negative number. This is going to be like minus 14 over 4, which we can transfer to the other side to become positive. And here we'll have 2 times 207 dy dt. And we'll try to make dy dt the subject from here. What we can do, it's what is dy dt? This we can still write as 14 is equals to 8 times root 207 dy dt. So dy dt is going to be 14 divided by 8 times root 207. Yes. So let's see if we can have an approximate value. It's fine. What is the root of 207? 207. We can have the root of 207. This is saying it's about 8 times, let's say 14.38. 14.38. Okay, so we have dy dt is going to be around 14 over, this is multiplication here, and this should be around 115099. Okay, so roughly, let's see what we got. 115.099. Okay, so dy dt is going to be roughly around 0.121, and this is going to be also feet per watt per second. Okay, so just a quick summary of what we did here. First of all, this is going to give you a triangle, a right angle triangle at any point, because you have a wall, you have a ladder leaning against the wall, so there is a right angle here. So we can use Pythagoras theory to find equation 1. This is true at any time t. Then you differentiate with respect to what? You differentiate with respect to t, because both x and t will be changing with time. And if you do that, we will have 2y dy dt plus what? 2x dx dt. Now, you know, what are we looking for? We are looking for what? If you look at what we're saying, how fast is the top of the ladder moving? So it means you are looking for what the change of this one, this value, this y. Okay, and here we use the x dt to be minus 1 over 4 because you are pushing towards the wall. You are pushing towards the wall. So you are pushing into the wall. So it's negative direction. Then, okay, and here, what did we do here? We said after 12 seconds, you need to find the distance, because if you are pushing in this way, after 12 seconds, you must have covered some distance here. So we want to find this short distance after you push for 12 seconds, the distance here. And what is this? Is simply by 10, because the original position, the original distance is 10 before you start pushing. So that's why we have 10 minus 1 over 4 times what? 12, which is time in second. And if you look at it, I use these units to see that this is going to give you feet. So you have 7 feet. Then you can go back and find the value of what? Of y. Then after you have the value of y, then just plug into this your derivative and try to look for your y. So as you can see, the y is what? Is positive. The change in y is positive, while the change in x is what? Is negative. And that is clear, because if you have a ladder here, by the time you push the ladder, if this is the initial ladder, original, by the time you push this side to here, what will happen to the top of the ladder? The top of the ladder will what? Will increase. The length of the ladder will remain fixed, but the distance will move from, it will move from here now to here. So that is why it's positive. All right. I hope it's clear. Thank you for watching.